Practice makes perfect, so we're going to spend another lesson practicing our order of operations to simplify expressions that have rational numbers.
Our first example is nice and challenging, but it's not impossible. So looking at this, we have subtracting and multiplying, decimals, and fractions. But we're going to start off with just this part over here. Just this part, this multiplication. And we're going to start there. And since they're both fractional, let's start off. I'm already looking at this 2 3/4 and thinking, let's make it friendly by just automatically changing it. 4 times 2 is 8, plus 3 is 11, so 11/4. So we're going to just multiply these two parts out, and we get 77 over 8. So that's our very first part. And I'm already looking at this 77, and I'm having thoughts, because I know I'm going to have 8 5/10 minus 77 over 8, and we have some decisions to make. First off, I'm not too interested in working with 77 over 8. It's a very complicated number. If I have to do any multiplying with 77, it's going to take me time and there's more room for error. So let's change this to a mixed number. I know 8 goes into 77 9 times, because 8 times 9 is 72, and that would leave me with 5 8s left. So what I'm really going to have here is 8 5/10 minus 9 5/8. And this is where you have to make a would you rather choice. Would you rather? And think logically, which is the method that's going to have less of a barrier for you, where you're more likely to experience some success. So would you rather experience 8 5/10 as a fraction, so 8 5 over 10, or we could even simplify that 8 1/2. 8 1/2 minus 9 5/8. That's option 1. Or should we change the 9 5/8 into a decimal? So 5/8, 5 divided by 8 is going to give us 6. 2. I get 45. Or would you rather do 8 5/10 minus 9 625 thousandths? So these are your choices. Which would you rather do? Would you rather keep them as fractions or keep them as decimals? Now, I'm going to model only one of these. I'm going to choose to actually model this one. I'd rather convert and work with the decimals than work with those fractions and have to deal, especially when I know I'm going to have to subtract 9 5/8. There's just a lot happening there. So I'm just going to choose my decimal, but there's no right or wrong answer. That's my choice. I'm sticking to it. I'm going to just continue out here on the side. So 8 5/10 minus 9 625 thousandths. I'm going to rewrite this as an addition sentence, so using additive inverse. And I'm adding a positive and a negative. I'm going to have to subtract because there's going to be a zero pair, and just looking at it, I know I'm going to have more negative. So I know my answer is going to be negative, because 9 625 thousandths has a greater absolute value than 8 5/10. But I know I'm going to subtract them. I'm going to stack just this way. And I stack my decimals. And look how much easier it is to subtract now. And I get 1 and 125 thousandths. So my final answer is negative 1 and 125 thousandths. So we're going to hit pause here so you can jot down all your notes. You can see step 1, where I literally just started off with this problem here. And then I went to step 2 to do the next step in my work. Let's do our next example. And another wonderfully complicated problem is just another challenge. The challenges have solutions. They just take time. So let's do the same process again. 6/10 plus parentheses 2/5 minus 1/4 divided by 1/6. So here we have 3 operations. Using our order of operations, we're going to start here with our parentheses. So I'm just going to put a 1, and just so you know where we started with the parentheses, 2/5 minus 1/4. Our common denominator is 20. 5 times 1 is 5. 2 times 4 is 8. And I get 3/20. So that's our first one. So let's rewrite our problem. We have 6/10 plus 3/20 divided by 1/6. So in our order of operations, what comes first? Addition or division? Division comes first. So we're going to do 3/20 divided by 1/6. Remember, dividing fractions is the same as multiplying by the reciprocal. That's where people do keep, change, flip. We changed it to multiplication. We flipped it to 6/1. And we have 18/20. Now, before we move forward, I know we're going to have to do our last step of adding. Whether we add with decimals or add with fractions, I would love this to be a friendlier number, and we can simplify it. So we're just going to do that here. We're just going to simplify it. I can divide both numbers by 2/2. So let's do that. 18 divided by 2 is 9, and 20 divided by 2 is 10. So 9/10. And now we have our third option. We have now 6/10 plus 9/10. And this is where we get to make a decision again. So would you rather, and the first option is decimal, so 6/10 plus 9/10. See how easy that is to convert. Or would you rather do 6/10 plus 9/10? Both seem pretty good. Now me, I'm just going to stick with the fractions because I like fractions in this example. But they're both going to give you the same answer. I'm going to stick with the second one and get 15/10, which is the same. I'm running a little bit out of room, as 1 5/10, which can be simplified to 1.5. If you had kept it at a decimal, you still would have gotten 1 5/10, which is the exact same thing. They both would have given you the same answer. It doesn't matter. But that was our third step, the third part in our process. And so our final answer is 1.5, or 1 5/10. So you can hit pause here and let's jot this down into our notes. Well, great job, Math Marble. The trick with any of these, and they're not tricks, it's just they're challenges, and just chunk them into pieces by pieces using all the knowledge that we have. Take your time, make your work visible so you can anticipate where errors might happen, and make real decisions about how would you rather work with numbers. Is it easy to work with decimals or fractions, and where are you going to find the most success? We will see you in the next video.